Hidden in the depths between Iceland and Greenland lays the largest waterfall known to humankind. It is estimated that every single second, 5 million cubic meters of freezing Arctic water rush down the gigantic slope of a massive ocean ridge to form the largest underwater waterfall in the world. To understand what causes this very special waterfall, we first need to understand what drives the currents of the ocean and what kind of topography gives birth to these enormous dimensions of the Denmark Strait cataract. The ocean currents. Ocean currents can generally be split up into two distinct categories, each one having different causes for the movements, and both play a vital part in explaining how this underwater waterfall is created. The most obvious cause for ocean currents is the wind, which sets the very top layer of the ocean into motion. This movement then pulls on the underlying layers of water molecules, setting even more water mass into motion. These pulling forces are transferred down to a depth of up to 400 meters, and they drag along everything in its path. The global wind patterns are the main force to create the currents, but gravity, the shape of the continents, and the Coriolis effect give these upper ocean currents the final direction. Another cause for ocean currents, which is usually found in the deeper layers, where the wind's impact cannot be felt anymore, is the so-called thermohaline circulation. Different temperature gradients and salinity levels split the water layers apart, and this separation causes a chain reaction of several giant areas of water being repelled from each other, and as a result getting pushed around the ocean floor. From a global perspective, this thermohaline circulation creates quite steady, deep-sea currents which span the entirety of the planet. Both of these forces result in largely overlapping global current systems. When the flow of the currents is interrupted by continents, islands, or ridges in the ocean floor, one of the layers may change course and go into a path of collision. The result in this scenario would be that the warmer stream shoves itself above the colder one, which subsequently increases the pressure on the colder one and pushes it down and away from the collision area. The Denmark Strait. This is exactly what happens in the narrow strait between Iceland and Greenland. The so-called Denmark Strait receives large amounts of deep cold water from the so-called Greenland Current, which flows southwestwards along the coast of Greenland, while warmer surface streams split up from the North Atlantic Current, aiming into the Denmark Strait in a northeastern direction. These two currents now meet exactly in the narrow strait between Iceland and Greenland, causing the water from the Greenland Current to be pressed down by the Atlantic Current. The topography. This interaction alone wouldn't form a waterfall though, and colliding currents can be found in large and small scales all over the planet. What makes the situation between Iceland and Greenland unique, however, is the fact that it occurs right on top of a 3,500 meter tall underwater cliff. Whenever a tectonic plate transitions from being continental to being oceanic, the transition is usually not smooth when spectated from far enough away. This is also the case for the transition of the Greenland landmass towards the center of the Denmark Strait, which consists of a narrow strip of oceanic plate. The ridge, which formed at the edge of the continental bound, now creates a steep slope in the southwestern direction. When the two currents explained previously collide in this area, the colder Greenland current gets pushed down immediately upon crossing the ridge, making it fall down this massive 3,500 meter tall cliff, which makes it the largest underwater waterfall in the world. The height and the amount of water which is in motion here dwarfs every comparison to traditional waterfalls found on the surface of planet Earth. The Angel Falls in Venezuela is the highest waterfall found on land, and the 979 meters of the South American giant are a mere 28% in height compared to the Denmark Strait cataract.